Oh, all right. Yeah, great. Great, great. Are we going? An array or symbol? An array. An array. Sorry. An array. When I say array, so arrays. I'm doing arrays.
Hope everybody had a good 4-day weekend. It seemed a little short, huh? Not enough time. I had some time finally. Created a bunch of visual studio projects for us, but then they're still at my house. So, oh no, so I created one of them. Got a whole bunch for you. In the next few days, we'll be doing a lot of hands-on stuff because we've got to look at creating methods and creating classes. So for this week, which is just today as far as class goes, we're in chapter 4, and chapter 4 is kind of fragmented. So let me see if I can bring it up for you to see what I'm talking about. So make sure I'm in chapter 4 here. Sometimes I don't know if I like all these parts and things because it makes it hard to find things. Chapter 4 starts out with arrays. We won't really be talking about arrays until after spring break. We'll come back to that. So you can skip that section if you like. It's up to you. And go straight to page 119 in section 4 where they're talking about methods and parameters. Now again, if I look at that chapter, there are some other things that they cover. Let's get into that. Like the enum type, the structure, aka value type, and then the next couple topics, value and reference types, and some other things are things that we'll talk about again as we go through. And some of it's just material that you're only going to see in your book, and we'll try to add into any of our projects that we can as we go through. So really methods and parameters, value and reference types, and nullable types are the primary topics in that chapter that we want to cover right now. Like I said, we'll come back to this chapter after spring break to pick up the other topics as we move around. So many different ways we can present the material, and no matter what, there's going to be pieces of it that don't make any sense until you find out about something else. That's kind of the way programming and working with computers is. You're always wishing you understood the next concept, and you will. So encapsulation, what does that have to do with methods? Well, we'll see. Encapsulation is an object-oriented programming term, and we'll be talking about object-oriented programming pretty much in depth next week. But methods are actually involved in encapsulation. It's going to work. My thingy doesn't work. Come on. Oh, darn. Okay, I'll just click. Maybe that doesn't work either. Nothing works. So what is encapsulation? Here's a picture of it, or a few pictures. So in the middle, I have some greenery and some dirt and stuff encapsulated in this crystal that's some sort of award for all this valuable service. And then over here, I have a piece of paper that's encapsulated within a couple of sheets of laminating paper. So either way, they're encapsulated. And then lastly, I have a smartphone, and it shows you encapsulation because we have the front cover and the back cover, and all of the parts that are encapsulated within there are hidden from us, and we don't really have to worry about those parts, right? We know they all come together to make that phone work, but they're encapsulated inside there, meaning we don't have to worry about them. They're protected and hidden. So it's kind of a way for us. Whoops, we're going to create a program, visualize some more boxes here of additional methods that go with this program. So our program is going to start out with our main method, and we're going to call a method called display instructions. That method's going to write some stuff out to the console to tell our user what's going on in our program. Then our main method is going to call some additional modules to gather input and finally display an output message. So we'll work on this hierarchy chart as we go to get things added to it so that it's a little bit more complete. So what about that display instructions method? What is a method anyways? Well, depending on where you came from, as far as your 120 class, you might have heard of different types of subprograms. Subprograms are just pieces of logical code that we've pulled out to make their own subprogram, their own logical instance. So these pieces of code might perform one logical function. They might be related to each other. It might just be that it's ugly code and we want to get it off someplace, so we put it in a function somewhere, in a subroutine somewhere, so that it's off by itself. But no matter what, when we modularize our programs, make it easier to work on our programs, make them more simple, each module becomes simpler in effect. And then we have all of these pieces that can fit together and make a good full product. So for C#, when we have subprograms, we call them methods. And in C#, it doesn't matter what kind of method it is. It doesn't matter if it returns a value or doesn't return a value or does any other weird things. It's still a method. So there might be some special methods, but it's kind of only one word that we have to remember for a subprogram. It's just a method. So whenever we look at a method, we have some things to be aware of. First of all, we have a method header, just like any other programming language, that instructs the system that this is the beginning of a subprogram. Now, when we're working with C#, we have some prefix words that go along with the method name. So in this particular method, we'll come back to those prefix words in just a second. Here's our method name. This whole line is our method implementation, the signature of our method. So we have our method signature, and then we follow it with open and closing curly braces. And everything inside the opening and closing curly braces is our method body. So whenever we run or call that method, we're going to execute all of the lines of code within that method body. So what is that method signature or method header made of? It's got a lot of pieces. It can be kind of overwhelming at first, but after you get used to it, it's pretty easy. I'm going to bypass that word static for now and say that the first thing I have to have in a C# method is this word that specifies what the return data type is going to be from this method. So when I'm working with a subprogram, often I'm going to return some value, like they ask me to figure out what the sum of these two numbers is, and I'm going to return that sum. When I do that, I know that that data type is something specific. It could be a string, an integer. Because C# is type specific, remember, it's type centered, we always have to specify that data type. So we're not saying what the name of the variable is, nothing like that, just what data type it is. So the keyword void means there is nothing returned from this method, no data type. Then we have our method name, display instructions. After our method name, we have open and closing parentheses to indicate that we could have a parameter list. This method has an empty parameter list. That's why the parentheses are empty. Nothing in there. So that's the specifics that we have for our method header. So the minimum I could have is the keyword void and my method name and the open and close parentheses. So I have to have those. Now when I want to call this method, I'm going to put in a statement, a line of code that just specifies the method name. After the method name, I'm going to have open and closing parentheses, again to indicate the parameter list that's being passed to this method. Now when I issue this statement to call this method, control is going to branch to that method. So the CPU, the processor, is just executing away line after line of code. It hits a call to display instructions. It's going to branch control to the beginning of that method and start executing the lines of code within it. So let's create our little program here. let's get started and let's create this display instructions method. We're going to come back to this and add a little bit more, but I want to start out, let's open Visual Studio. Now I know I just jump right in here with methods, so let me know if you have any questions or things from last week. And I know you guys were working on unit exams and all that kind of stuff. Be taking a look at those, see if you run into any issues. Now I want to create a new project here. And we decided that this was chapter 4. And I'm just going to call this chapter 4, Practice Methods. And that's all I need. Make sure that it's a console app. Everything looks good. I'm ready. This program that we're going to create is going to be kind of like an audio application. We're just going to have a couple of questions and display some output. Let's rename our program.cs file. Let me get my other project up here. What do we want to call it? I'm going to rename it, and I'm going to call it CD Tester. Now we're going to see that as we get into more advanced stuff this week and next week, that our program.cs file becomes kind of a driver, kind of a tester to control things. And we'll start out naming it that today, getting used to that. So in our main, I want to declare some variables. For our program, we're going to keep track of some things. So we're going to have a string variable that keeps track of an album ID. And then we'll have a string that's the album. And of course, we could make it a CD or whatever we wanted it, but we'll just use that word album. Now, we're going to keep track of how many tracks are on that album so that we can work with an integer. And we're going to keep track of the cost associated with that album so that we can work with a decimal, so we can get all these different pieces kind of put together. And then I was thinking it would be nice if we were able to personalize our program with the person's name that we're working with. So let's set up a string. We'll call it username. And of course, we could prompt the user and ask them for their name, but let's try this environment variable that is available through Windows 10 and see if it works. So I want to use environment dot username. And if you noticed when you type the dot, the IntelliSense editor dropped down with a whole list of different environment type variables that are available to you. So we'll see how it works here. Works great at home for me. Now we have these variables defined. We're going to use them as we go. But for now, we really just want to display some instructions. It's always better if we go ahead and declare our methods or kind of outline our code before we call those methods. That way we don't have to worry about errors. So I'm going to come to the end of my main method. I'll label that closing curly brace so I know where I am. And then the end of our class. And after that, we have the end of our namespace. So I want to come to the end of our main method. I want to put this new method after our main method. So our new method, we said it's going to be void because it's not going to return a value. it's just going to display instructions. So I'm going to do the opening and closing parenthesis to indicate that there's no parameters. And then my open and closing curly braces to start my method body. I want to do a console.write line, so I'm going to back up and fix my using clauses. Using static system.console. And then we're ready to put this one line of code in here. We're not going to have a lot of instructions. Let's write something out. Welcome to the audio track. So this is our first method. I'm going to go ahead and put a comment on its closing curly brace. This is the end of our display instructions method. And then if we look at the method up above and add some comments, if you do the 3 slashes, you'll see that Visual Studio will pop some comments in there for you. All we have for this method is the summary and end summary. Oops, falling apart back there. So we want to use those as best we can. So for our comments here, void is the keyword to indicate no data is returned. And then display instructions is the method name. And finally, the parentheses indicate no parameters. Now, if I put a call to that method, it needs to go in my main. And to call it, I just say its name. And then I'll put my open and closing parentheses to indicate there's no parameters being passed to it, and my semicolon. I'm getting an error. What about you? Let's Google it. Did you guys figure out what the problem is? Tell me what's going on.
There's no static.
What's that mean?
Should be a public static void, if I'm correct.
Like where?
When you're calling display instructions.
So in our method header?
Yeah.
Yeah. So we have to have that keyword static because we're calling this method from our main method. And if you look at our main method, it is a static method. Now, static is important. Static means there's only one instance of this method in memory. For our program, that might not make a really big difference. But if I were working for a company where throughout the whole world, there were connections being made to the corporate office and they were getting the next available invoice number from the company, I would want to make sure that there were only one of them, right? And I wouldn't want multiple processes running in my company that supplied the next invoice number, or I'd end up with a big mess and I'd have all sorts of duplicate invoice numbers. So you can think of a static variable as that kind of thing. It's a singleton. There's only one. And so whenever we're using our main method to call other methods, they all have to be static, which is a huge limitation to us we'll see next week when we start looking at creating classes. So we want to make sure that we don't use that unless we have to. Actually, using static is a very good thing because that limits how much memory is going to be used if we can. So if we're working in an instance where we really only have one of something, being static is a very good thing. Okay, so let's see what we could do if we want to run our program. I'm going to put a read statement after our call to display instructions because I want that console to hang for us for a second so we can see our instructions. Again, our instructions are short. Just welcome to the audio track. So let's run it. And you should see your message pop up. Everybody's working okay? Working? Now let's use the debugger and watch what happens when we call that method. For the debugger, I want to set my breakpoint right here at this display instructions line. And remember, you're going to come all the way over to this gray bar on the left and just click on that same line of code that you want to set that breakpoint on. Or you can right click and choose add breakpoint, or you can use the breakpoint menu and add breakpoint, however you like to do it. And then let's run. Remember, you have to use this icon to run it for the debugger to work. If you use the F5 thing, it disables the debugger. So I'm going to start running my program, and I stop right away waiting for me at my display instructions call. Now notice your locals window down here at the bottom. You should be seeing all the different variables that we had set. My username is not super friendly. It got my login name. So at home it got my whole name, but that's still okay for getting an environment variable. I like that for you guys to have that sample code to see how to do that. And then you can see our other variables. Our strings are null. Our number variables are set to 0. We have everything there. So now we can step into our code. So up in your toolbar, you're looking for that step into icon, or you're going to press F11, either one. When you step into that line of code, you should see it begin to execute. So control should branch to your display instructions method. And sure enough, there we see it's sitting at the opening curly brace for that display instructions method body, ready to start executing that code. Now if I click step into again, we go to our write statement. It writes out our information to the console. Then we get to the end of our method body. And when we click step into again, we return back to our main. And then if I step into one more time, we should be at our read where we can see the console display. So yay. Now when we're working with a really small program like this, I'm going to turn off that debugger. Using the debugger, again, can really help. Actually, I don't know of any time that using the debugger can't help, because it's always a helpful exercise to walk through your code and see what's going on and see exactly what's happening. So everybody's okay, because we're going to add a lot more to this one. So if we've got any problems, we want to get them taken care of while we're early. Let's save all. Okay, so what we want to do is we want this program to do a little bit more than just displaying instructions. Let's add now a parameter so that when we call our display instructions, it is user sensitive and it displays that user information. I'm going to go to my display instructions method header, and in my parameter list, which is my parenthesis, I'm going to say I have a parameter. Now, when we declare a C# parameter, we have to start with the data type. Remember, C# always wants to know, what type is it? What type is it? What type is it? It won't do anything unless it knows what type it's working with. We're working with a string here, and we're going to call it user name, because user looks mad. Now, when I say that, now, when this method gets control, username will be a variable that is allocated as a string as that method begins executing. So that variable will be available to us within that method body. but only within that method body, not anyplace else. Now I want to take that username and add it to our output message. Now that's all good. We've said here we're going to use this username. I need to change my comments though. I'll add that string username indicates a string parameter called username. So anytime we see a data type, we're kind of declaring a variable, right? And we are there, we're just declaring a variable as a parameter instead of using a regular declaration. Now, if I tried to run my program, I'd get an error because the call to my display instructions method is not passing in that parameter. What do I want to use? My username variable. So when we call a method, the parameter is passed by name, and we don't have to worry about the data type. So when we are declaring our method, we specify the data type and variable name. When we're calling it, we just have the variable name, because that variable should already exist. Now, if you run it, you should see that user ID come out with your message. There we go. Is it working for you guys? I'm not calling you any weird things? Okay, good. So methods are easy. They can look kind of confusing though when you look at them. So let's create another method then. We have this other data that we want to prompt for. We've created a method to display our instructions. So in our hierarchy chart, display instructions. And then we have a string or two that we'd like to prompt our user for. So let's say we're going to create a method called input string, and it'll take care of getting all the strings for us. And then let's create a method input int, and it'll take care of getting that integer parameter for us, and if we had any others. And then we'll declare one to do doubles, or decimal, I guess. We made that variable decimal. And finally, to display our output. So our program will be all logically broken up, and we won't have to worry about any sort of complicated logic going on in any of those methods. They'll all be super easy, each and of their own. So I want to come to my display instructions method, and I'm going to find the end of that method. Now, when we declare our methods, right now I am not including the public or private access level. By default, these are all going to be private, which is what we would want, right? Because this is all just one program that's in one class, so we'd want everything to be private. But I'm really leaving them off just for simplicity's sake so that we can minimize how much code you have to have for each one. But as we get further along, we'll add those in and start using them quite often. Now, I'd like to get, first of all, a method set up to prompt the user for the ID and the album. So that's going to be our input string. So we'll start out again with that keyword static, because we're going to be calling it from our main. It has to be static. This one is going to return a string because we want to prompt the user for a string value. And we're going to call it input string. Now we have a couple of strings that we could use this method for. We could use it for the ID that's a string and the album name that's a string. So let's make a parameter for our prompt. And then that way we can just use this method for both of those things. So in this method then, I'm going to do a write statement. And I'm going to prompt for some, oh, and I wanted to show you guys something. Last week, whenever we were doing some output statements, showed everybody this new style that you can use with this version of C#, so it is very new. And you can put a $sign before the beginning of your string. And it's got some weird long name, and I'll have to think of it. I will think of it as we're doing it. But when you put the $sign in front of the string, then you can put a variable name in your string within your curly braces. So for example, this one I could say, please enter, and then within curly braces, the variable name prompt. Now what we've seen before is we would have had, without the $sign, a 0 here, and then a comma with our prompt variable name. So this is just a newer style of letting us output without having to do all of that different parameter replacement. Yes, sir?
What if there's two variables? Do you still use it?
Uh-huh, and we will. So we're going to say, please enter the prompt, and then we want to return whatever our read line statement gets from the user, because this is a string, so we don't need to do any work with it here in our method. We're just going to return it directly back. So in order to try some more of this, let's add an output statement in our main, and we're going to fix this later, but just for debugging purposes. So in our main, we need to add a call for our input string, but I'd also like to add an output write statement that just writes out all of our variables so that as we add code, we can see that our variables are working properly. So let's do it. I want to use the write statement, and I'm going to use the $sign, and I'm going to start this with a new line. And then I'm going to put album ID, and I want my ID variable to be displayed for that. It's just giving me an error because it hasn't been initialized. So we'll set it to an empty string. Now I want to continue on with this. After our album ID, we're going to do our album. We'll call it name. I'll just call it album since that's what I said the variable name was. A little errors because C# is like, you didn't set these two initial values, so I can't use them in a write statement. So let's go ahead and set them to initial values. I'll set an empty string. We saw when we were using the debugger that they really are initialized to 0 and to an empty value. But the compiler is taking care of us, making sure we don't mess anything up. It's like, nope, not going to let you. Get rid of those errors. Now, the next line that I want to output is going to be the number of tracks. It messed me up. I'm going to move all my colons to be lined up. Now the next one is going to be our cost. Now, after all of those write statements should be our read statement so that we can see everything. Get everything. I've got ID, album, number of tracks, and the cost. So that looks good. Let's run it and see if we get some good output. I've got something wrong with my cost. Ooh, I didn't put in a \n. That could be a problem. So my output is hopefully looking decent. So now I need to add in my call to that input method. And what I want for this very first time, I want to use my input string method to get the album ID. So I'm going to use the return value from that method as our ID. So I'm going to call our input string method, and I want to pass it something as a prompt that says album ID. So now when we call our input string method, we're passing a parameter that contains the value album ID, and the return string we're going to place in our ID variable. So let's run and see if we get that. Awesome. So let's set it up in your debugger. I'm going to set up a breakpoint here where we call input string and run it. And you should see that it gets called exactly the same as our display instructions method. It's just that we didn't really have any parameters or anything set up when we debugged that one. Okay, so first of all, when I start the debugger, I'm sitting here ready to call my input string method. If you look at your locals, you'll see your username variable is already set because we've already executed that line of code that went out to the environment to find that information for it. Now I want to step into, now it goes straight to my input string method. Right now, my prompt, if you notice, is already set to album ID. So that passing in of data occurred right as that call was made. If I keep pressing F11, I should see my output message on the console. I might have to bring the console up to actually see it. Yep, there it is. It's waiting for me now for that album ID. So I'll type something, click and type something. Maybe. It's not quite there. It heard me. It just didn't display what I typed. So it can be kind of weird when you're working with the console, just clicking back and forth. But you can see how you're stepping through that logic and what's happening when you execute those different lines of code. Now, we've got this method created to input a string. Let's just use that same method for our album name. I'm going to turn off my breakpoint, and I'll put in the same thing for my album. My variable name is album, and I want to prompt the user for that value by using our input string method. And we'll ask for the album name. Now we're using that same exact input string method, just sending a different value as our prompt. And so if the user types things properly, the result should be the album name. Let's run it. I'll enter an ID and then the name. It's all coming out fine. Everybody okay? Working? Save, save. So let's create a method then that prompts for our integer value. I'm going to create the method first. So I'll scroll down and I'm going to put a comment the end of our input string method. And create a new one. Now this string is going to return an integer. We're going to call it input int. It is going to expect a string that is a prompt also, so that we can prompt our user for whatever input it is that we need. That is an integer value. For this method, we're going to need to declare an integer to use temporarily. We'll call it temp. We're going to start out with that priming read, asking the user to enter whatever it is that we want here. For this one, we want the number of tracks. I'm going to do that $ string. So I want to say enter the prompt. Now we saw last week or the week before that if we did a while command, we could say while we were not getting a good try parse. Now the try parse, we want to look at what was passed in through the read line statement, and if it's a valid integer value, we want to output it into our temp variable. If we get an invalid value, we'll output that message, invalid value, and then we'll repeat our same prompt. That will be the end of our while body. And after that, then, we're ready to return that temp value. Because we know it's a valid integer. We finally got out of our while loop. It must be a valid integer. That's going to be the end of our input int method. Let's try it. Let's see, it's going to ask me for my album ID and my name. It didn't ask me for the number of tracks. Why is that?
There's an issue on the, hold on.
Okay.
No, never mind. Well, maybe.
Something else?
Didn't call it.
Didn't call it. Let's call it. Let's call it after our album name call. So for this one, we're looking for our num tracks for data. And we want our prompt to say number of tracks. What's cool about this one, when we call methods, it can definitely be confusing at first, but it's the same in a lot of different languages, right? This is not that different even from Python. It's just that semicolon at the end. All right, let's try it. Okay, so I got my album ID, album name, 3 tracks. It's a really short album. Okay, all that stuff is showing up. Looks good. So we saw that when we call the method, execution branches. Whenever you're looking at a method, remember it's just like a black box. So it has input, the parameters that we pass. It has output, the values that we return. But that method itself is a black box inside there. We don't need, as a non-programmer or as a programmer using somebody else's method, somebody else's code, we don't need to know exactly what's going on there. All we need to know is what input is required and what output is returned. So remember that, that's kind of like black box programming, an important term. Now what is actually happening is we're passing as input parameters to our method. Why is a method encapsulation? I showed you those pictures at first of like the grass tied in the crystal. Well, a method is actually containing all of these things. Input parameters, return values. We could have data fields like our temp variable could be contained within a method. We could have algorithms running within our method. Nobody needs to worry about any of those things. They're all encapsulated, hidden within that method. All they need to worry about is what input they have to supply and what output they're going to get from that method. So that's an important beginning term for object-oriented programming. Then we don't have to worry about what's inside there. It's encapsulated inside the method, hidden. Now we saw that static keyword. It's in the presentation, so you can look at it there if you need to. We didn't look much at private and public as our access modifiers. Like I said, we'll start looking at those a lot more next week when they start making a really big difference. Because next week we're going to be doing multiple classes. So then we need to worry about whether something is public or private or protected or internal. So those are our primary access modes. But notice our method header can get a little long, can get to be a lot of different things. Now this slide shows our parameter list where we have to have the data type followed by the name and passing that parameter in. Now when we have a value to return to our caller, we just use that return statement. The return value must be of whatever data type we have specified in our header. Whenever we're making a call, we're going to save that data, that return data, in a local variable. Now we've always been limited in C# to returning one variable, one data item, but we can get around that in a lot of different ways. We'll be looking at that next week when we talk about our classes, but there's also a data type that's recently become available in C# that is a tuple or tuple, got to say it right, and it gives us the capability to save multiple pieces of data within one variable too. Now, if we have multiple parameters that we want to pass to something, we're going to have a comma separating those parameters within our parameter list. So we could have a string and an integer that are both required as parameters for this method. When we pass those in to the method, again, we're going to specify a comma to separate them. Next time we'll look at this. Overloads, whenever we're working with a method, each method has that complete signature. The signature is a lot more than just the method's name. It also includes the return value and the parameters that the method expects. So if you see a test question, can you have two methods with the same name? Sure you can, as long as they have different return types or parameter lists, they are a unique method signature. So we'll try some of those next time. So encapsulation with methods helps us hide the implementation details. Nobody has to worry about what is happening inside that method. So it acts as a black box. Our methods help us implement modular programs, and each method should have a specific logical function. They help make code reusable, and they make code more understandable and maintainable. Now, did any of you guys have people that have said you can only have 4 lines of code in a method or 5 lines of code? There's all sorts of different things. Basically, your methods should be small and maintainable, and if you start seeing them turning into a large thing, they should probably be split further into more logical functionality. So we want to make sure that they just do one thing. A method should do one thing. Like in our case, input a string or input an integer, but it's not going to do a whole bunch of things. So sometimes we like to make them do too many things. So for your lab time, in the program that we just did, the first thing that we need to do is, where am I? Hang on, I got the wrong one. Click. All right, so we just put in a method to input an integer. We need a method to input a decimal value. So I want you guys to create that on your own with others. So you'll want to come first and using your input int method as a model, create an input decimal method. And then you'll want to call it to get your cost variable. So see what you can do there. I'm going to give you about 10 or 15 minutes to see how everybody's doing.